Imagine perfectly tracking a game-winning pass seamlessly across a stadium during a negative 40-degree blizzard, except, there is no human operator freezing their hands off to get the shot.
Right, which is wild to think about.
Totally. So welcome to today's deep dive. Today we're looking at the $10,995 piece of hardware that is making that a reality for modern live production. You are looking at the Bolin Technology EXU248NW X Ultra A PTZ camera.
And, almost 11 grand is a massive investment for a single camera. But when you break down the actual mechanics, you realize this is a highly specialized piece of autonomous broadcasting equipment.
Yeah.
It's literally built for the harshest environments on Earth.
Okay, let's unpack this because the optics on this thing are just absurd. We're dealing with the Sony 1-inch 4K sensor.
Which is huge.
Yeah.
In the broadcast world, bumping up to a 1-inch sensor gives you this massive light-gathering capability.
Right, meaning those notoriously dark stadium corners suddenly look crystal clear.
Exactly. And then they pair it with a 48x Zeiss Variosonar T lens.
You are pulling a tight, perfectly clear shot of a player's face from the nosebleed section. It's basically like slapping a high-powered telescope onto a 4K cinema rig.
Yeah, it really is. But, a cinematic 4K sensor is completely useless if the lens fogs up. Or, I don't know, if the motor seizes during a December football game.
Oh, for sure.
That's where the physical engineering comes into play. This isn't meant for a climate-controlled studio. It carries an IP67 rating.
And that doesn't just mean it's water resistant.
No, IP67 means it is completely dust-tight and can literally survive being submerged in water. A blizzard or a torrential downpour just doesn't phase the internal electronics at all.
Okay, but wait, at negative 40 degrees Fahrenheit, wouldn't the lens just freeze over and become useless? I saw that extreme operating range, and my immediate thought was condensation would just ice over those delicate Zeiss optics.
You'd think so. But the specs show it features a localized automatic preheating system. It kicks in the exact moment ambient temperatures drop to 5 degrees or less.
Wait, really? But how does applying direct heat to the housing not, warp the glass or mess with the focal length?
Well, because it's heavily regulated. The system doesn't just blast heat like a space heater. It actively manages a microclimate inside the housing.
Oh, wow.
Yeah, so it ensures the mechanical pan and tilt belts remain completely pliable and the glass stays clear of ice, all without causing the thermal expansion that would instantly ruin a shot.
Okay, so the hardware survives the elements, but the software is what's truly doing the heavy lifting out in that blizzard.
What's fascinating here is how it behaves once it's actually mounted out there. It isn't just passively recording wide shots. The architecture integrates the Freed protocol directly into the hardware.
Wait, hold on. I thought this was for broadcasting sports or news. Why does an outdoor camera need Freed? Isn't that protocol meant for VR studios and augmented reality?
It is, yeah. But that exact same ultra-precise axis data, the constant feed of exactly where the lens is pointing, panning, and tilting in three-dimensional space, is what enables true automation.
Oh, I see.
Right, so broadcasters take that free data and feed it into sophisticated tracking software. Instead of a person physically working a joystick, the software uses that spatial data to intelligently and smoothly pan, tilt, and zoom.
Just automatically following targeted objects with ultra-low latency.
Exactly. It completely transforms the camera into a highly precise, automated robotic operator.
That automation changes the entire workflow, and it's routing all that data out incredibly efficiently, too.
Yeah, the true tri-output capability.
Right, so it's simultaneously pushing SDI, HDMI, and IP video streams. In live production setting, a technical director can pull a zero-latency SDI feed directly into the swisher for the network broadcast,
while simultaneously pushing an IP stream to a remote off-site production crew across the country.
Exactly.
And the crucial detail here is that each stream can be set to independent formats. You might need a 1080p feed for the live broadcast truck, but a full 4K stream for archival or digital delivery.
And you get both instantly without having to rely on external outboard converters.
Yeah.
So for you listening, whether you build control rooms or just are fascinated by the evolution of high-end tech, this really redefines the category. You aren't just deploying a lens out there. You are installing an automated, weatherproof broadcasting studio on a pole.
Could not have said it better.
Which leaves you with a pretty massive question to ponder. If software can completely automate a camera to perfectly track moving targets, manage its own internal microclimate, and push 3 independent broadcast streams simultaneously from the middle of a freezing blizzard, what exactly does the future hold for human camera operators at major live events?